focusing on pattern questions. I'll be looking for them by going through all the different school papers. Yeah. So is this? Yeah, this is a pattern question. Okay. So here's an example of a pattern question. Let's take a look. So identical wall tiles are laid in a pattern as shown. 5 rows are formed. Find the area of one tile. The area of one tile. So the area of one tile is actually this shape. Let me draw it. So one tile is actually this shape, yeah. So the area of this looks like a semicircle. If you were to cut it here, right? So this part is a semicircle plus 2 arrowheads. Okay, so it's a semicircle and 2 arrowheads. So what is the radius? So the radius is 7. So this is 7, this is 7. Now if the radius is 7, then what is the, we can find the area of the semicircle. So semicircle it's half times pi times 7 times 7 pi squared. 77 cm squared, right? So that is the semicircle. Now then the next thing is how to find this arrowhead. Okay, let me draw a red color. This is called an arrowhead. So how to find an arrowhead? We got to take the square minus quadrant. Okay, you take a square minus quadrant. Now this square is 7 here and 7 here. So it's actually 49, take away the quadrant. Now quadrant is half a semicircle, so that is 7 divided by 2, 77 over 2. So we get 7 over 2, 10.5. So one arrowhead is 10.5, two of them will be 21. Okay, so this 10.5, so the area of one tile is just 77 plus 21, okay, 98 cm squared. Okay, so that's 98 cm squared. Next, find the total area covered by the 5 rows of tiles or form. So row 1, 2, 3. Okay, so one row has 1 tile, 2 rows, 2 tiles, 3 rows, 3 tiles, right? So 5 row, the 5th row will have 5 tiles. Yeah, so 5th row will have 5 tiles. So well, altogether, how many tiles are there? So it's 1 plus 2 plus 3 plus 4 plus 5, 6, 10, 15 tiles. So we take 98 times 15. So 98 times 15, 1470 cm squared. Okay, so this is from Maristella. It's a pattern question. Okay, so Bala uses shaded and unshaded squares to form figures that follow a pattern. The table below shows the number of unshaded square for each figure. Complete the table. So 4 and 5. Okay, so what is the trick here? Now what I like to do is I like to look at the look at the increment here, right? So here to here is plus 3. Here also plus 3. So likelihood is this is plus 3 as well, and this is plus 3. So the plus 3 is 14, this is 17. Okay, so I'm going to have 14 and 17 there. All right, next. What's the difference in the number of unshaded squares Bala uses for 11 and 14? For figure 11 and 14. Okay, so I already have this. Okay, let me leave it here. I can see the question. Um, 11, 14. Because you keep adding 3. Difference in the number of shaded, unshaded tiles for 11 and 14. Now, the trick here is to see the pattern. Now, some of you might keep adding 3, okay? But what is the faster way? The faster way is actually to see that, you see here is we add 3. So for figure 1, it's 5 because it's 2 plus 3. see figure 1, 2 plus 3 equal 5. For figure 2, 2 plus 3 plus 3 equal 8. Right, figure 3, 2 plus 3 plus 3 plus 3. Okay, can you see the number of 3 increases with the figure number? Right, it corresponds to the number of figure number. So what do we do here is the multiply. We use multiplication. So it always starts with a 2 plus 1 time of 3, 2 time of 3, 3 time of 3. Okay, so on and so forth. So if we were to look at figure 11, 2 plus 11 times 3, that will give us 11 and 33 plus 2, that's 35. Right, figure 14, 2 plus 14 times 3. Right, it's 42 plus 2 is 44. So if you take 44, take away 35, it's 9. Okay, so that's one way. Yeah, that is you find the actual figure. But there's another way. The other way is to realize that between figure 11 and 14, it's a difference of 3 figures. So every one figure difference is 3. So 3 figure difference will be 9. So 3 times 3 gives you 9. Okay, next. Another figure in the pattern has 20 more unshaded than shaded. What is the total number of shaded and unshaded squares in that figure? Okay, so now we have to find the difference. So the difference here is 1. This plus 1, 4 plus 1 equals 5, plus 2, plus 3, plus 4. Okay, see the pattern? Plus 5. Now it's plus 20. Now if the difference here is plus 20, can you see it corresponds to this? So plus 20 must be figure 20. Okay, what's the total number of shaded and unshaded figures? For figure 20. Okay, let's find the number of unshaded figure. For figure 20, unshaded, it's 2 plus 20 times 3. So it's 62. Now shaded, we have to minus 20. So it's 42. Because 42 plus figure 20, as we have shown here, will give you 62. So what is the total number of shaded and unshaded? 42 plus 62, 104. Okay, so the answer is 104. So that's the pattern question from River Valley. Okay, so each figure is made of identical lines. The first 4 figures are shown below. How many lines are needed to form figure 101? Okay, so let's see the pattern. Actually, pattern questions are not that bad, yeah? So figure 1 has got 1, 2, 3, 4, 5, 6. 6 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 lines. So you see it's plus 4. Likelihood is plus 4. 1, 2, 3, 4. So plus 4 equals 14. 1, 2, 3, 4 plus 4. 16. There it was 16. Oh my god. 14 plus 18. Okay, so can you see we keep adding 4 plus 4 plus 4 here. Okay, we start with 6. So this is like 1 time. How many lines I need to form figure 101? So figure 1 just 1 time of 4. So it's 2 plus 1 time of 4 equals to 6. Okay, 10 is 2. Let me use another color. 2 plus 2 times of 4 gives you 10. 2 plus 3 times of 4 gives you 14. 2 plus 4 times of 4 gives you 18. Okay, so this number corresponds to the figure number 3, 2, 1, 1, right? So if it's figure 101, 2 plus 101 times of 4. 404 plus 2, 406 is the answer. All right, should be correct. Next, the figures in the pattern are made of dots. How many dots are required to form the figure 5? So let's count. Yeah, let's count them. 5 dots. 1, 2, 3, 4, 5, 6, 7, 8 dots. 4, 5, 6, 7, 8, 9, 10, 11 dots. Okay, so we can see that this plus 3 as well. Okay, so figure 5, you can plus 3, you will get, and then you need to plus 3 again. I mean, this is the simplest way to do this. So plus 3 is 14, plus 3 is 17. So this figure 4, figure 5. So figure 5 is 17. Write down the number of dots in figure 50. So what's the sequence? Right, the sequence is 2 plus figure number times of 3. Okay, how does it work? Let's try. Yeah, if it's figure 1, 2 plus 1 times 3 equal 5. Correct? Yes. Figure 5. 2 plus 5 times 3 equals to 17. See? So it works, all right? So how about figure 50? 2 plus 50 times 3 equals to 152. So that's 152. Okay. So which figure has 269 dots? This one got to work backwards. Now 269, what you do is you have to take 269, take away 2. So we get 267. Then 267 divided by 3. 267 divided by 3, 89. Okay, so the answer is figure number 89. Oh, here it is. Okay, John uses triangles and circles to form figures that allow a pattern, shown below. Okay, complete the figure. So 1, 2, 3, 4, 5, 2, 3, 4, 5. Here has to be 6. Yeah, 6. 6, 8, 9, 11 plus 2 plus 1 plus 2 is 12. Plus 3 plus 2 plus 3 plus 2, 15. Yep. Yeah, that's right. So a figure in the pattern has a total of 51 triangles and circles. What is the figure number? The pattern has a total of 51 triangles and circles. Okay, so total number 51. What is the figure number? Okay, so now I need to find the pattern. 1, 2, 3, 4, 5. 2, 3, 4, 5, 6. Number of triangles, 2, 4. Figure number. Now I have 51. Yeah. So the difference between triangle circles 4, 5, 4, 5, 5, 6, 6. No, not useful. So this plus 3 plus here. Okay, I'm trying to look for pattern. Yeah, plus 3 plus 2 plus 3 plus 2. Right, so the pattern is plus 3 plus 2 plus 3 plus 2. So groups of 5. Every 2 pattern, that means from 1 to 3, you have to add 5. So wait, that's 51, 2, 3, 4, 5, 6. 6, 8, 9 plus 2 plus 1 plus 2. Okay, groups of 5. So this is one group, yeah? So one group from 1 to 3 must plus 5. 3 to 5 must plus 5. Starts from 3. So 51 minus 3 equals to 48. Not helpful. Not helpful. Okay, so 6, 8, 9, 11, 12. Because it's somewhere in the middle. Somewhere in the middle, minus 2, minus 7. 51 minus 7. 4, so cannot. It's multiple of 5. 1 times This plus 1. Okay, so is it usually if you cannot solve this, one way is to do the long method, yeah, which is to keep adding. You plus 5 plus 5, but what I'm going to do is I'm going to add 5. So you see here, I have 18. So how many times, what do I need to add to become 51? So 51 minus 18 is actually 33. So it's 6 groups of 5 and then 1 tree. 6 groups of 5. Okay, this is called one group of 5. Yeah, so 6 groups of 5 from, oh, I know, 6 groups of 5 from 7 groups, it's actually 7 groups of 5 from 16. Okay, do that again. So 51 minus 16, 35, 7 groups of 5. Yep, so 7 groups of 5 means there's 7 groups of this. So 7 groups of 2 numbers, 7 times 2 equals to 14. I take 14 plus 4 equals to 18. Right, so figure 18. Figure 18. Okay, so how many circles did John use for figure 115? Wow. Figure 115. Figure number, okay, so if it's figure 115, number of triangles always add 1, so it's 116. Number of circles, plus 4 plus, oh man. Triangles add 1. Number of circle. Oh, okay, I have no idea number of circle, but I know it's figure 115. So if it's figure 115, from figure 5, I gotta add 110. That means 110 divided by 2 is 55 groups of 5. Okay, so 55 groups of 5 is 55 times 5. I need to add 275. 55 groups, 110. From 5. So I got 18. So 18 plus 275, 293. Okay, so total number here is 293. So how many circles are there? 293 minus 116. 177. Okay. Yeah, let's try whether it's correct. It's a little bit question 15. Yeah. See, 177, 18. Yep. So here is a little bit tough because you need to group it according to groups of 5. What's the question? Yeah. Right. Okay, so you cannot just look at 1 here to here because each step, right, has got different increments. There's like 3 and 2, but you can group them together as groups of 5. Okay, so I solved this using groups of 5. Well done, Henry Park. This is actually pretty tough. Okay, SCGS pattern question. How many triangles are needed to form pattern number 25? 1 plus 4 plus 5. Number of pattern number 4, number of straight lines. Okay, let's find the pattern. Here, just keep adding 2, yeah? So plus 2 plus 2, right? So you keep adding 2, you will get that number. How many triangles? For pattern 25. So 2 plus figure number times 2. So 2 plus figure, let's test, yeah? Let's say figure 3 times 2, I get 8, right? Then figure 25, so it's correct. Figure 25, right? 2 plus 25 times of 2 equals to 52. Okay, so for figure 25 is just 52. That was fast. Next, which pattern is made up of 217 straight lines? Okay, now I want to find 217, yeah? So 217 straight lines. I need 217. The pattern here is plus 3 plus 3. Okay, so what is the formula? Is 1 plus figure number times 3. Okay, you realize that this 3, I will put it into here. Okay, so let's test. If it's figure 1, 1 plus 1 times of 3 equals to 4. Okay, let's test if it's figure 3. So if I change it to 3, it's 10. Is it correct? Yes, correct. So now I want figure 217. No, I mean number of lines 217. So I got to work backwards. So I take 217 minus 1 equals to 216. Then 216 divided by 3. So give me the figure number. 216 divided by 3 is 72. So answer is figure 72. Next question. What is the total number of triangles and squares given for pattern 48? Pattern 48. Okay, so number of triangles and what? Squares. Triangles and squares. Oh, triangles and squares. Okay, so they didn't, okay, we only have triangles. Pattern number is equals to the number of squares. So I just need to find triangle. Pattern 48. So how many triangles are there in pattern 48? Pattern 48, yeah. So to find triangles, I use this method. So 2 plus 48 times 2, 96, 2 plus 96 equals to 98 triangles. And how many squares are there? Since it's figure 48, so 98 plus 48 equals to 146. Right? So number of triangles and squares is 446. Okay, pattern. So the figures are made of squares, but how many squares are there in figure 13? Alrighty, so how many square? Figure 1 has 1 square. 1, 2, 3, 4 square. Figure 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 square. So here plus 3 plus 5. Yep. I mean, we're going to try one more. If it's figure 4. Figure 4 will look like this. 1, 1, 2, 3. 1, 2, 3, 4. No, sorry, 5. 1, 2, 3, 4, 5. And then here will be 7. Okay, so 1, 2, 3, 4 plus 7. You add 7, yeah. So 1 so plus 7 is 16. Okay, so of course you can keep going, yeah, but is there a pattern? What kind of pattern can I use to solve this? There's a secondary pattern actually. Meaning, okay, meaning here plus 2. Okay, second level. We keep adding 2. So figure 1 plus 2. Figure 13. Okay, I really don't want to go all the way to 13, yeah? Just keep adding, or you can just use a calculator, 1 plus 3 plus 5 plus 7. Yeah, I'm going to do that, okay? Because it's faster. So once I reach, you see, figure 1 is 1, figure 2 is 4, figure 3 is 9, figure 4 is 16. Okay, so figure 5, so you see here, plus 3 plus 4 plus, no, it's not plus 4, it's plus 5 plus 7. So the next one will be plus 9. Yeah, but it's troublesome. Plus 9, 9 times 12. Let's try. So 16 plus 9 is figure 5. This is when you have no choice, okay? Lazy to find the 25 plus 6, 7, 8, 9, 11, 12, 13. Okay, so plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21, 23 plus 35. Okay, this is when I really want to find the answer, but I don't want to find what's the working in between. So 25 plus 11, 36 plus 13, 49 plus 15, 64 plus 17, 81 plus 19, 100 plus 21, 121 plus 23, 144 plus 25, 169. Okay, answer is 169. Yeah, so this method is when you have no choice because I don't want to find what's the algorithm in between. Okay, so I do this way. 169. Yeah, then 13 times 13. Oh, wait, I didn't see the pattern. Oh, yes. Okay, yeah, so the pattern is just square. Let's see that. Okay, so this is 9. This is 2 square equals 4, 3 square equals to 9, 4 square equals 16. So figure 13 is just 13 times 13. Yeah, so 13 square equals 169. Honestly, I didn't see that. But it's fine. Okay, you get the answer. Next.